Yes, you should. Very, very disrespectful. I need a one-word synonym for rational. Rational numbers are what kind of numbers? Yes. Now the real numbers, that's a giant group of numbers. The real numbers, this giant group of numbers, right? And inside that group of numbers is one called the rational numbers. I'll give you an example. 2/3 is a rational number. So is -3/5. So is 17/18. What am I describing? Fractions. So the one-word synonym for rational is fraction. Any number that can be written as a fraction is in this group called the rational numbers. I'll tell you what's not in there, pi. Neither is radical 2. Those cannot be written as fractions. So I hope that you understand that what we're going to be writing as answers to this will be considered fractions. You'll also notice in this question that they're asking you for a list of possible fractions. What they are not asking you for are the actual solutions to this question. Nowhere in this question does it say, give all the solutions to this question. It is only asking you to use a theorem called the rational root theorem. The rational root theorem is what they're asking me for. We'll abbreviate theorem THM. Now, the rational root theorem says that we need the factors of the constant divided by the factors of the leading coefficient. Factors of the constant divided by factors of the leading coefficient. Okay? Up here, can you tell me what the constant is? What's the constant in this particular? 2, thank you very much. So, I need every number you can think of that multiplies together to give you 2. Okay? Now, I'm going to write positive and -1 and positive and -2. The reason I'm doing that is because you know that you can take 1 times 2 and get 2. But you could also take -1 times -2 and also get 2. So to abbreviate that, we'll just put plus minus 1 plus minus 2. What's my leading coefficient here? 1, right? My leading coefficient up here in front is a 1. And the only numbers I can think of that multiply together to give me +1 are positive and -1. Now I'm not saying, I'm saying +1 times +1 and -1 times -1. But to shorten it up, I'm saying plus and minus 1. So factors of the constant go on top. Factors of the leading coefficient go on the bottom.
So what the answer be?
You're ahead of me. You're ahead of me, but I want to explain why. But yeah, you're right.
I thought the answer was really good.
Okay, now, if you take all 4 numbers that you see on the top and you divide by plus and minus 1, well, let's just do this one at a time here. What do you get when you take 1 and the plus and minus 1 and divide by plus and minus 1? You get plus and minus 1, right? So in my list of answers, I need to have plus and minus 1, which automatically gets rid of which choice? Which one of those doesn't have plus and minus 1? C. If you take plus and minus 2 and divide by plus and minus 1, what do you get? plus and minus 2, which is why answer B is correct. Those are the only possible options we have. Now, we did say possible because it doesn't mean that they are. Remember last Friday I would give you hints. There are not 4 rational numbers that go into this polynomial, I can guarantee you that. But out of all the rational numbers of the universe, the only possible ones are these 4. In pre-calculus, we would actually ask you to figure out which ones of those would be the solutions. But you know, in my class from last week, we talked about giving you hints. And after you were given those hints, what were you supposed to do with those hints? Long division or synthetic division, we have been doing synthetic division only. If you're a big fan of long division, congratulations, do it. Okay, but that's what we would do. This question doesn't ask me to do that. All right, question 2. My constant is a 9. Can you think of all the numbers that multiply together to give me 9?
1 and 9.
1 and 9, yep, that's true. And 3 and 3, right? So 1, 3, and 9 would be the factors of the constant. What about the factors of the leading coefficient, which is 21? What kind of things go into 21?
7.
Let's start with the easy ones, like 1, but 7 is in that list too, yeah. What else? 21, yep. And 3. 1, 3, 7, and 21. Okay, so walk me through this. If I take these 6 numbers on top and I divide by plus and minus 1, what do I end up getting? Yep, plus and minus 1, 3, and 9. Therefore, which choice can immediately be eliminated? C, right? Down here you see that the 9's not in there. Okay. What if we take these 6 numbers and divide by plus and minus 3? So what's 1 divided by 3? Well, that's 1/3, right? Isn't that in all 3 of the choices? So that doesn't help me get rid of anything yet. How about 3 divided by 3? That's 1. We already have that one in our list, so that doesn't help me. How about 9 over 3? That is 3. That is also in my list. That does not help me. Okay. Moving on down the road here, we'll take these and divide by plus and minus 7. Is 1 over 7 a new value? It sure is. 1 over 7, 1 over 7. Oh man, we didn't get rid of any of the choices. Okay, how about 3 over 7? That's a new one, right? Okay, do we have any that have 3 over 7?
Yes, B.
B? Oh, D does not. Don't be fooled by that right there. 7 over 3 is not the same thing. So we have found our answer. Okay. We could also see 9 over 7. All right, that's down here at the end. What about, let's pick a different color. What about 1 over 21? Okay, that's in the list, right? How about 3 over 21? I don't see 3 over 21 in the list. Oh, that's 1 over 7. We already have that one. How about 9 over 21?
That's 1 over 3.
No, it is not. Good try. But you're on the right idea to reduce. 3 over 7, and we do already have that one. So, choice B does have all of the correct answers. All of the correct possibilities, I should say. I know question 1 was a lot easier than question 2, but it illustrates the point. All the factors of the constant over all the factors of the leading coefficient. Okay, so factors of 3 on the top, Factors of 10 on the bottom. Go. And don't worry about this second part of the question. Just worry about factors of the constant on the top, factors of the leading coefficient on the bottom. On the bottom, but also 1 and 10 have to be on as well. All right, let's start the process of dividing. Yes, start the process of dividing. Take these two, divide by that one. Good choice. So factors of 3 would be 1 and 3. 9 does not go to 3. So just plus minus 1, plus minus 3, those aren't there. Then I go to the 10. What things multiply together to give me the 10. Trying to kill me.
Is this right?
You have them reversed, so these need to be on the top. 1 and the 3 need to be on the top. So a lot of you had the 1 and the 3 on the top, and then what on the bottom? 1, 10, 5, and 2. Okay, and it doesn't matter what order you put them in. Really, it doesn't. Okay, so don't. If I take the 1 and the 3 and I divide by the 1, what do I get? Don't I get positive and negative 1, positive, negative 3? Can you tell that it's got to be, it cannot be letter A because there's going to be more values than just that, right? So that's a pretty ridiculous answer. Okay. So move over. So now I'm doing plus minus 1, plus minus 3 over plus minus 2. That would give me 1/2 and 3/2. The only one that has 1/2 and 3/2 in it is letter C. Yes, you can go further. You can take them and divide by the 5 and get 1/5 and 3/5. Then you do 1/10 and 3/10. And yes, they're all in letter C. But as soon as you start to see that, oh, well, this one doesn't have that one, well, then you can get rid of it as an option. In pre-calc, we would go further. We would take this list of 2, 4, 6, 8, 10, 12, 14, 16 different numbers, and we would plug them in looking for the ones that gave us 0 so we could do synthetic division. 16 different numbers I got to plug in to find something that works? Okay, that's why I give you the hints on those types of questions. Okay, a little bit of a review question here. Write a polynomial of least degree, we'll say in standard form. And it has to have these two zeros, -4 and +8. If I were you, I think I would start with factored form first and then change it to standard form. So factored form first, standard form second. Use pink for anything because my brand name would be not pink. That's what my brand name would be called. Okay, do you think I'd get sued if I used that? If my brand name was not pink, and then every piece of clothing, every item was, we could never use pink. We wouldn't sell, I don't think we'd sell much in the month of October, but you know what I'm saying. We would still. That's be my own brand, and we would just everything but pink. No, and then we would call it not pink. What? No, I'm just saying. Do you think I would get like sued from the Pink Corporation?
No, but I'd buy.
Because mine would be not pink. There's an idea, man. Okay, marking. Okay, so there's your idea right there. Go not pink. And then every other color in the universe can be used for all your clothing except that one. I just think it's hilarious when I see something that says pink, but it's not pink. I'm like, come on. Are you what's going on with you people here? I know. Same thing that, that all the cows say. It's just a brand. So, yeah, yes, they do hurt. I'm guessing. Okay, if -4 is the 0, what's the factor? There's got to be an x in there somewhere.
X minus 2.
Whoa.
I'm wrong.
We're starting with -4. I need to come up with the factor. Some of you, I think, are on the right track, but I'm not sure I'm getting the right factor. X plus 4. That's the factor that we get from the 0. Okay, tell me the other one. X minus 8. Okay, so this is what we call factored form, and they're asking me specifically for standard form. So what am I going to do with these? How do I change this into standard form? Remember, standard form looks something like this. Or for a quadratic, it would look just like this. Now, it doesn't have to have equals 0 on it or anything, but... Sorry, too far. What am I supposed to do with those two factors? Multiply them, okay? Let's take a trip down the Foyle Road. Follow the silver Foyle Road. Okay. Oh, nice job. You're gonna snap it. Nice. Awesome. You're ahead of things. I like it. Excellent. Yes, foiling. Nicely done. Foiling. Oh no, he's already ahead. Get them foiled. Okay, do you like boxes or no boxes? No boxes, so you need to draw arrows. So you need to pair up. You need to pair up the outsides. You need to pair up the insides. And then you need to pair up the laps. Okay. And then add any like terms that you have. That's why they use that. Yes? Okay, I know. So x squared, What's the next term if you take the outsides and insides and add them up? Minus 4x, and the last would give me negative 32. Okay? Whether you like boxes or not, I'm a big box fan, but you know, some people cannot. Yeah, I know. Some people hate it. Okay, question 5 says, I'm going to modify it a little bit. Find the maximum number of roots. Instead of using the word roots, we'll call them zeros. It's the same concept, or similar concept, I should say. Okay, remember when we did the end behavior, we used words like up and down? This goes back to your section 5.1 notes. I believe it's either 5.1 or 5.2. I think it's 5.1. I'd have to look at a copy here. Find your end behavior for me. So find the right and the left end behavior. Okay, use words like up and down. So we got the left end behavior and the right end behavior. We always started by finding the right end behavior first. Which term am I really paying attention to for end behavior questions? Which one of those terms am I paying the most attention to? Which one tells me what I need to know for the end behavior? The leading one. So you should be paying attention to the 5x to the 5th to make your decision about the right end behavior and the left end behavior. Yeah, that was 5.1 if you're looking back at notes. All right, what'd you decide? The leading coefficient is positive 5. What does that tell me about the right end behavior? We know that it's going up. Okay, then we have an odd degree. What does the odd degree tell me about the left? It's going opposite. So there's a trip down memory lane from last week. If that's true, and we know it goes up on the right and down on the left, what's the most number of times? Stay with me. Okay. What's the most number of times you can see that thing hitting the x-axis?
Like 2 times, right?
So you're saying, well, okay, let me envision this with you. So we could cross through here. You're saying if it's only 2 times, then it would bounce off the axis to do that.
So 1.
3 times? Okay, 3 times would be like, okay, cuts through once, cuts through twice. But guess what? That's not a 5th degree polynomial. That's a cubic polynomial. 5 times is the most it can cross the x-axis. I do agree with you. Let me show you what it would look like. That's the most number of times. 1, 2, 3, 4, 5. Okay? All right, I'm going to make something else up. Oops, not that. I hope so. Okay. Y equals x to the 4th minus 17x cubed plus 2. It's got a leading term of x to the 4th. What's its end behavior going to look like? It's got a positive 1 for the leading coefficient. What do you know about the right? It's got an even degree. What do you know about the left? It is the same as the right. Now, if that's the truth, then we know that it's doing this. It's going up and up. What's the most number of times you can see a 4th degree hitting the x-axis. 1, 2, 3, 4 times. Now, could we do less than that? Sure we could, but the question asked me, what's the maximum number of times? Now, a 5th degree, the maximum was 5, and a 4th degree, the maximum was 4. So what in the world should you have been paying attention to when you answered this question? The degree. The degree was the answer to the question. It has a maximum, I should say, maximum of 5 roots. Yes, the degree tells me the most number of times you can hit the x-axis. Okay, a little bit of review from last week. We need a couple hints. This one is hint. -1 is a 0. Okay, so what are we going to do with that -1? What are we going to do with that -1? What are you going to do with it? Synthetic division, aren't you? Okay. Go. I'll figure out the hint for the next one. We're going to get these 2 questions done, and that'll be the end of our therapy session for today. Better get a remainder of 0 when you're doing this. Make sure you did your synthetic division correct and you get your remainder of 0. You did. Yeah. What did you find? What is this thing that we found? You need to be able to look at this and identify what this thing is. What is it? Yep. Well, what expression is it? X squared minus 2x minus 35. Is that factorable? If so, you need to factor it right now. So x and x, right?
Yeah.
Then what? What factors should I be using? 7 and 5. Which one gets the negative?
5.
The negative goes with the 7. The positive goes with the 5. Because you got to end up with a negative 2x in the middle. Now, answer the question. What are the 3 answers to my question?
1, 7, 5. 1, -7.
-1 for sure. Where'd that come from? That was the given hint. Make sure you don't forget that one. It is -5 and +7. Remember, if you don't recognize this, set the factors equal to 0 and solve them. That's what we've done over and over, and obviously if you're good enough at it, you don't need to write that down. But if you're wondering where that came from, that's it. Okay, move to question 7. You got a new hint. 2 is a 0. Use it. Let's make this our last one, so we'll zip through this one. I'm going to use the space down on 8 because we're not doing question 8. So if you need some space, you can drop down here. 3, 8, -33, and 10. What? So 2 times 14 is 28. Which is great because that adds with the positive 10 gives you 0 on the bottom right, which is exactly what we want. Should have gotten a remainder of 0. Now what is it that you're looking at now? 3x squared plus 14x minus 5. So now my question is this factorable? The answer is yes, but this is going to take me back to, you're either going to be guessing and checking. The only things that multiply together to give you 3x squared are obviously 3x and 1x. Or if you're not a guess, if you don't like to sit there and guess and check, we could use the Berry method, which is what we did in class a while back, where we took the 3 and multiplied it times the -5, and that gave us x squared plus 14x minus 15. What does this thing factor into?
5 and
What multiplies together to give me, well, 15 and it's 14 away from each other? It's got to be plus 15 and minus 1. And then what magically happens in front of the x's? What comes back? The 3 comes back. And now we're looking for GCFs we can get rid of. Does the first one have a GCF we can get rid of? A 3, and that would leave me x plus 5. The second one does not have a GCF that I can get rid of, so it is 3x minus 1 times x plus 5. So can you give me at least 2 of the 3 answers, if not all 3? We have 2, we have -5, and what's the last?
+1.
It's actually positive 1/3. You would have to set the factor equal to 0 and solve it, and that's how you would get 1/3. So that one's kind of an ugly one.